Hey guys, welcome to Technical Ecology. I'm Kalpapran and I am a biodiversity conservation student. Well, at least I was a biodiversity conservation student at Nottingham Trent University. I recently graduated with a distinction, so that kind of feels good. Anyway, in today's episode we are going to talk about arrays and matrices in R. So this is the third episode of our R series where we talk about different ecological concepts and the basics of R that will help us get a more wholesome understanding of ecology in general and how to use programming in ecology, especially when dealing with different form of numerical data. Okay, with that being said, let's get into today's video. Today's video is going to be fairly short because I have seen that when I was preparing the script for this episode, it was really long, and I decided I would divide it into 3 parts so that we can have the best of both worlds and not get distracted by longer videos. And especially I don't want to make it sort of a lecture where I'm talking about it and you're listening, and after a while your attention span just plummets. All right, let's get into the screen now and let's get started. There you go. Alright, so what I want to talk about first is Matrix, and by Matrix I don't mean Keanu Reeves' Matrix, not that movie. It's an amazing movie though. What Matrix is basically in mathematics is basically a two-dimensional vector. Like usually when we spoke about vector in the last episode, it had only one dimension to it. Like we had C in brackets 1, 2, 3, 4, 5, so those are the 5 elements in one vector. But when we talk about matrices or matrix, we talk about 2 elements, which is the x-axis and the y-axis. So it has a row and it has a column. So every element in a matrix has its own index, like a vector, a single dimensional vector had its own index, like we saw in the last episode. Even a matrix has its own index, but it has 2 elements to it. An index which signifies the row and an index which signifies the column. So let's get into it. First we'll talk about matrix and then we'll talk about arrays, where arrays I think I'll talk about it in the next episode, like the second episode of the matrix series within the R series. So let's get started. So as you can see, matrix is basically several vectors stored together. Size is defined by the number of rows and the columns. So 2 by 2 matrix is different, a 3 by 2 matrix is different. And when I say 2 by 2 or 3 by 3, the first number 2 or 3, like when it's 3 by 2, 3 is the number of rows that I'm talking about, and 3 by 2, 2 is the number of columns I'm talking about. So you can see that it's basically a 2D structure. Matrix is a 2D vector, and each item in an array has a specific location. Even in an array and even in a matrix, this can be matrix as well, this word has its own specific location. Let's see how to create a matrix. So to create a matrix, what you need to do is I'm creating a matrix, defining a matrix to an object called A. So to create a matrix, you need to use the function matrix. So matrix for open brackets and then goes the data, which you can define, or even if you don't define data, it will still work. But then again, it's a convention that I'm teaching are from the basics. That's why I want you to know what every attribute means and what it is called. Like you can see, when we use the mean argument in our previous episodes, we define it as x equals to the mean of, let's say, whatever the object is. But here we don't use x, we use data, because the matrix function has stored data as the attribute. Like the entire function has data as an attribute, not x. So if we type in x, it probably might not work, but it might work again, depending on from which package we are extracting. And this is extracted from the core package of R, which defines matrix as data instead of x, right? So when I specify data equals to concatenation, concatenate 7 minus 7 1 789 0.76, that means that there are 4 elements in this matrix, and when I define n row is the number of rows that I want, that's 2, and number of columns that I want, that is again 2. So if I run this code and then I print A, you can see here that it makes a 2 by 2 column, so 2 rows 2 columns, so 2 by 2, 2 rows 2 columns, and the numbers are filled up whatever we have given. Now you can see here that the numbers are filled up in a certain way. It's filled up like -7 1 789 0.7. It's not like -7 1 and then 789 and 0.76. It's not filled up in a row wise fashion, it's filled up in a column wise fashion, and that is by default what the base function, the base package of R does. So I will show you how to change this fashion of filling up in the next line of code probably. So you can see here that we have defined the number of rows and the number of columns. But what if we don't define the number of rows and the number of columns? In that manner, like if I just run this, you can see it will always fill up the rows and one column. It will number of elements, so here we have 4, so 4 by 1 matrix. If we have 5, then it will make a 5 by 1 matrix. So let's say 8. So if I run it, you can see it makes a 5 by 1 matrix, 5 rows 1 column. So that's how the base package of our matrix works. Now that's the important reason why we need to put in the number of rows and the number of columns, because we always want a matrix to be of a certain manner. Now you might ask, why am I talking about matrix? So why I'm talking about matrix is, now when you get a basic idea of how matrix work, how to extract elements from a matrix, then you'll be more confident in dealing with tables, which we'll come back to later, because in ecological data, most of the data that we have are in form of tables. So we need to extract certain elements from a table, or delete that, or modify that. So all those will be much simpler if you have a basic idea of how an array or even a matrix works, right? So when I spoke about earlier that it is filled up in a column-wise fashion, if you want to change it to fill it up in a row-wise fashion, it's simple. Just use this attribute of the matrix function by row. Now here you can see, if I run this code, it creates a matrix in a column-wise fashion. It fills up in a column-wise fashion. But now when I specify by rows equals to true, then it will fill it up in a row-wise fashion. So -7 1 789 0.7, whereas in the previous case it was -7 1 789 0.76. Right. Now what if you want to make a matrix but you have different vectors? So somebody gave you, let's say, 5 vectors, and if both the 5 vectors have 4 elements in it, sorry, not both the 5 vectors, the 5 vectors have 4 elements in it, then you can join them and bind them together to make one matrix. But you need to keep in mind that this is only possible if the number of elements in each vector is same. If it's different, it's not going to work. It's not going to be a matrix. A matrix is always in a squared up form or in a rectangular form. So if it is, let's say, you have 3 elements in one and 2 elements in another vector, then it won't be able to form a rectangle or a square. So that's one thing to keep in mind. Right, so how to do that now? Again, it's very simple. There's a function called cbind, which binds the vectors by columns, and rbind, which binds the vectors by rows. So column bind, cbind, so these are the vectors that we have. C 4.8, 4,8, C2, 0. You can see that all the elements here are 2s. There are 2 elements. There are not more than 2, or they don't differ. Now what you can do is also have an object specified as, let's say, x, and then have 1,7, and then y, which has 4,8 in a different line of code, and then again just call x, y, and z, and then it will again bind them together. But just for simplicity's sake, I have done it inside one function so that it's easier for you to interpret. Right, let's see what happens when I run this code. So you can see it creates a matrix which has elements, like you can again see it is filled up in a column fashion 1 7 4 8 2 0. Now that's because we use column bind. Now what will happen if we do the same thing and we use rbind, which is row bind? It will fill it up in a row wise fashion. So you can see 1 7 4820. So that was basically about binding vectors. Now there is also a very useful function called dim. So dim is basically the dimensions of a matrix. So we had specified this matrix earlier, right? Like 2 by 2 matrix or whatever that was. Yeah, it was a 2 by 2 matrix. If you call the dim function on A, it'll give you the dimension, like 2 by 2. So 2 rows, 2 columns. Now this is again very useful in case of tables, because in tables we might have, let's say, 5,000 is a very high word, let's say 300 or 500 observations, which will always come in rows, and let's say 15 variables which will come in columns. So sometimes when we're dealing with many people, and when we're especially working in collaboration, they might not standardize the form of taking data. They might just give you, okay, this is the table I've got, there you go, you work with it. Now you don't know, you can go individually, you can go to Excel, import it in Excel, and then keep on scrolling to find the last row to get the number of observation, but that's very time consuming. So what you can do is throw it into R, use the dim function, and it'll give you the number of rows and the number of columns. So when you get the number of rows, you can know that, okay, we have, let's say 300 observations, and you get a number of columns, which say we have 15 variables. So yeah, that's basically the use of dim. Now, like, I know it right now everything seems so easy and you can't see the bigger picture here, but trust me, if we move along this entire R series towards the end, you'll see how these basic things play out a very important role later, because that will mold your understanding of R, rather than just, you know, jumping into the more complex thing and then getting over and over, and I'm like, R is not for me. It's very simple. I'm telling you, it's very simple, but effort is required. Anyway, again, the n row function gives you the number of rows, and n call, like dimension gives you the dimension 2 by 2, whereas if you just want a number of rows, you can use the n row function and n call function to get the number of columns. So let's just run it. You can see 2, 2. Now we have a 2 by 2 matrix, so it's just throwing up 2s. Later I will create a more complex matrix, which will help you see the difference. Right, now what I want to talk about is vector subsetting. By vector subsetting, or matrix subsetting, what I mean is, what I've written EP2 is because I want you to think about, or at least try and recall, what I spoke in episode 2 about subsetting data, how it is done. It is basically the same thing that we have used in EP2, in episode 2 here. So subsetting and deleting or replacing, everything is very similar, even in matrix. It's just that in a matrix you have two each index has 2 elements in it, so number of rows and number of columns, so you need to specify that. All right, so let's see what this line of code does. You can see I have called the dimensions of A. What will this do? Let's just break it up. So the dimension of A will give you 2 by 2, like we have got earlier here, dimension of A, which is number of rows and number of columns. Now this entire thing, 2 by 2, is stored in its own vector, right? Now from that vector, what if we want to extract the second element? So if you want to extract the second element, so this is 1, this index of 2 is 1, and this index of 2 is 2. So if we extract the second element, it will just give you 2. So you can see it's 2. Or let's just change things a bit to get more clarity on it. So 4 columns and number of rows is 1. So it will basically create a straight line. So if I run this, you can see 7 minus 7, 1. Right. Anyway, what I wanted to show you here is let's call the dimension of A now. What will happen? Let's see. So it's 1 and 4. Now 1 here is the first index, 4 here is the second index. If we run the same code here, so dimension of A, and if I run put it in square brackets 2, what we will get is 4. See? So dimension of A makes it into a vector which has its own index, and then from that we subset by using square brackets the second element, which is 4. Right, now let's just change everything up again to its original state. 2 by 2. Okay, let's run this once. There we go. All right, now let's talk about additional dimension. By additional dimension, what I mean is that in vectors, we, like in the last episode, we had just one element to it, like one element to each index, but now we have 2 elements to each index, right? So let's create this new matrix called A. And you can see here number of rows is 3 and number of columns is 3. So a 3 by 3 matrix. What will this do? So I just want you to pause this video and then go to the comments and then type out what will this line of code do, what will line 46 do. I'll wait and then you can come back. All right, so let's not run this line of code and I'll tell you what this line of code does. So A 2, 3. So what is 2 here? It's in square bracket, yeah? So we're subsetting, we're extracting something. So 2 here is the number of rows, 3 here is the number of columns. It's a column number and a row number, sorry. So when we talk about 2, the second element, the second column, let's go to the second column. So 2, yeah? And we want to know what is that same element which has second row and the third column. It's minus 45. So if I run this code, probably it will throw up minus 45. See? So it extracts minus 45. Now here you can see that there are 2 dimensions. So we gave both the dimension. Now if it was only a vector, so let's say we create just a vector for simplicity. Right. So I create a vector called x, yeah, and from x I want to extract minus 45. So where is minus 45 here? You can see that here it's 1, 2, 3, 4, 5, 6, 7, 8. So the 8th element, right? 8 is the index here. So if I run this, you get minus 45. Whereas in case of matrix, it's different. We need to specify the row number and the column number. So which is second row, third column. So if I run this, we get minus 45. Right. Okay, let's just get rid of this. Okay. Now, what if you want to extract all the observations or all the rows, but from column 3, but only column 3? So basically what we want is minus 5.78, minus 45, and 6.80. Sorry. So when we run this, you can see 5.78 minus 45 is extracted. How? So what you do is you don't specify anything for the number of rows, and when you don't specify anything for the number of rows or the row number, it'll extract everything. Same case for number of columns. If you don't specify any column, it will extract everything. So here what this function is, what this piece of code is telling is that from the matrix A you extract all the columns which is there in row number 2. So for us that will be row number 2, all the columns. So 6.34, 0.76, and minus 45. Let's run this. You can see that 6.34, 0.76, minus 45. You can also complicate things and say from 1 till 2, like from row number first row and till the second row, we want everything, like all the columns. So we can just run this. Now it's fairly simple here because it's a smaller matrix, but again, long term, if you have a massive table and we want, let's say, the first five variables, which is the first 5 columns, we want everything, all the observations from the first 5 columns. Then what we do is that we don't specify the number of rows, but we specify the number of columns. So let's say A is the table we have, and then A, open brackets, open square brackets. We don't specify the number of rows, but we specify the number of columns, which is like 1 to 5. You can also do C in bracket 1, 2, 3, 5, but that's again not efficient. So you just do 1:5, which extracts all the observations, that's all the number of rows, from column 1 till column 5, right? Okay, so you can see here what I was talking about, concatenate, or concatenate, whatever that word is. It goes in this column, in this square bracket, first bracket, from 2 and 1. So here I've specified 2, 1. That means first it will extract all the number of rows from column 2, then it will extract all the number of rows from column 1. Whereas if you just overturn it and make it 1 and 2, it will do the other way around. So let's see. So you can see it extracts all the number of rows from column number 2. Where is our matrix? Okay, I'll just print it here again. Here you can see it extracts all the element from column 2 first. It gives it a new dimension. So if you specify this to a different object again, then it will create a new matrix where column 2 of the original matrix is column 1 of this new matrix, and column 1 is column 2. So that's about it. And this one, actually I won't run this piece of code. I want you to run this piece of code and then probably see how things work in R. So with all these basic understandings from above, it'll be much clear. It'll be very easy for, like, even you can do this mentally. I can just tell you what this code does so that you can just run it and cross verify. What this piece of code does is basically it extracts rows, column 2 and second column and the third column, and the elements in that second and the third column which are in row 1 and row 3. So row 2, even though column 2 and column 3 is there, nothing from row 2 is extracted. Row 2 is not extracted at all, but all the elements of second column and third column from row 1 and row 3 is extracted, right? I want you to run this code and then see how it goes. Again, this function called diagonal, I do remember when I was studying maths in probably my 6th standard that we spoke about diagonals. I never got the use of it even up until now. I'm pretty sure there's some use and I'll come to know that later, probably during my PhD or something, but I never got the use of this, but there's a function for it, so I'll just show it to you. So when you use the diagonal DIAG function, it basically extracts all the elements from the diagonal of that matrix. What I mean by that is, this is matrix A, right? So it'll extract 7.5, 0.76 and 6.8. Okay, I just run it. There we go. You can see 7.5, 0.76, 6.8. If you know what's the use of this, like why are the diagonals extracted, please let me know. I mean, I think it is useful in chi-square test, but I can't seem to recall it. Anyway, how to delete or omit observations from a matrix. Again, it's a very similar thing. You can see I have used -2. Now it's again self-explanatory that 2 here is the second column. So what this piece of code is telling is that, okay, from the second column you want to delete all the variables, all the observations of all the rows. So basically what this piece of code does is that it deletes the second column altogether. So all the rows, I mean all the observation, all the rows are deleted from the second column. Basically the second column is thrown out, right? Same thing here. It's a tad bit complex, but not that complex. So it tells R to extract second column and the first column, and then from that it wants to delete the second the second row. So what that will do is it will extract 2 and 1, and from there it will remove the second row. So it will have an element called 7.5, 23, 568 and 103. So let's run this. So you can see that 23, 7.5, 103, 568. Right. Here what it does is it deletes the third column entirely, and it deletes the second column entirely, second row entirely. So if I run this, you can see third column gone, second row gone. Right. What do you want to overwrite? Oh god, I think I'll be falling sick. I'm having a sore throat. Anyway, we have almost come to the end of this video. Like I told, it's a short video and it's helpful for me to edit it as well. Like, jeez, I hate editing. If somebody wants to edit my videos, please drop down in the comments. Right. To overwrite data is again similar to what is used in the second episode in vectors. I spoke about something called vector recycling, right? Again, recycling is done here as well. We'll see that. Like, see, we'll see it in code 82. All right. So for now, let's create another object called B, which contains the same elements as A, but we'll work with B because we are changing data, right? I want that A to be constant throughout because I'll be using A later in the next episodes as well, right? So let's create a new variable, an object called B, which is exactly the same as A for now. Now what I want to do is I want to select the second row and all the columns. So basically the second row, I'll extract 6.34, 0.76 and minus 45. And what I want to do is replace it with something. I want to replace it from 3 to 1. Let's say 3 to 1. Right, 3 to 1. I want to replace the second row from 6.34 to 3, 0.76 to 2, and minus 45 to 1. So I just run this piece of code there. There we go. You can see if I print B, you can see that the second row is absolutely replaced now. We have 3, 2 and 1 instead of 6.34, 0.76 or minus 45. Similarly here from the second column, so now B is modified, yeah, so it's not this one, it's this one. So the second column, 23, 2, 103, and from there the first and the second row, so which is 23 and 2, I want to replace that. I want to replace that with 56. So 23 will be replaced by 56 and 2 will be replaced by 56, but since the row 3 is not mentioned here, so it will still stay 103. Let's see if I'm correct. Yeah, that is. So 56, 56. Now this is the new B matrix. It's no longer the previous one, so it's changing. And now you can see why I assigned a different object to it. Okay. This is quite interesting. I was just playing around and I found this. So what if you want to change, you want to select a certain column, you want to select you want to select a certain column and make that a row, right? So how you do that is using this command. So what basically I did here is I selected all the columns there, but the second row, so all the columns 1, 2 and 3, but I selected the second row, so it's 3, 56 and 1. From there what I did was I said that okay, from this same matrix, what you do is you select the second row, second column, and all the elements of all the rows. So 56, 56, and 103. So I told R to replace this line by this by 56, 56, and 103. So what this will create is a matrix which has, say, 56, 56, 103. So what it does, it takes this line of code and then it replaces with 56, 56, and 103. So 56, 56, 103. Okay, vector recycling. Right. We are almost coming to the end of this video. but this is the last concept today. REMEMBR. Okay, right. We have seen that in vector recycling, what it does is when we have, let's say we have 10 elements in a vector, a single dimensional vector, and from there I specify R to replace 6 elements from it, but we have provided R with only 4 elements. So what it will do is it will go sequentially and it will replace the first and second and third and fourth element with the elements that we have provided. But then for the fifth and the sixth element, it will recycle, it will replace, it'll like go back and then it will replace one with the first element and the second element that we have provided. Same thing happens in matrix. What happens is, like you can see here that I have selected two rows and 2 columns. So I've selected C1, 2. So I'm selecting the first and the second row and the first and the second column. So what I'm working here is with 7.5, 56, 56 and 56. Okay. What I'm telling R is that I want to replace these elements, these 75, 56, 56, 56 with 8 and 5. Now I want 4 elements to be replaced with just 2 elements, which it can do by, again, vector recycling. So what it will do is it will fill it up in a column-wise fashion, because I told earlier that this thing if you don't specify it, it will always use a column-wise filling fashion. So what it will do is it will create a vector of 8, 5, 8, 5, 5.78, 103. All these stay the same. So let's see how it goes. Yeah, you can see here 8, 5, 8, 5, and all the elements are same. So it doesn't go 8, 5, 8, 5. It goes 8, 5, 8, 5. It goes in that manner because, again, column wise, R works in a column wise manner. So with that being said, we have come to the end of this part of the matrix series. And I think we'll have another 2 episodes, depends how long each episode is, and then we will talk about, I don't know what we'll talk about. I think we will I'll figure that out when I'm making the videos. Thank you very much for watching today's video, and I hope to see you in the next episode. Take care and have a nice day. Right. I hate smiling on the camera. My face hurts.